We're looking at Algebra 2, Section 11.2, Probability. Okay, so 11.2, Probability. Now, there are really two types of probabilities. We talk about experimental probability and then theoretical. Let me get my spelling. Once again, I'm the math teacher, not the English teacher, so let's try to spell this correct. Theoretic. Oh, okay. Now, when we talk about experimental probability, number one keyword right here is, let me circle it in red, experiment. Okay? We have to have some sort of experiment going on. Okay, so the probability of an event to happen is going to equal the number of times the event occurs divided by total number of trials. Okay, so we have to have an experiment. Okay, this is where we could talk about flipping a coin 10 times and getting ahead 6 out of 10 times. Okay, so if I were just to think, I'm going to switch to orange here. So if I flip coin 10 times, get head 6 times. Okay, this means my probability of a head is going to equal 6 out of 10. Which would be 3/5. So we're seeing that our probability is 3/5. Now, under theoretical probability talks about the probability of an event is going to equal, let's see here, how can I phrase this so it would be simply stated? The number of chances divided by total number of chances. Okay, so if we were to consider just the probability, so let me come back here, the probability of a head. Okay, instead of chances, I should go outcomes. Let me go outcome. So number of favorable outcomes versus total number of outcomes. Let's change that word around. Favorable outcomes to total outcomes. So when we talk about a head, there is one head on a coin out of 2 outcomes. Okay, so this is where we can get in some discrepancies, and we could say, well, this is a 0.6 probability, but here it's a 0.5 probability. So we could have things that might not seem the same, once again, because of that experiment that goes into this. Now, do realize in that experiment, we have to have our overall aspect that's going on. We have to have some sort of simulation that's happening, and it has to be a repeated simulation. Okay, so we'll get into simulations down the road in some of our later sections on how we have to go about doing things. But this is our basics of probability. Once again, between theoretical and experimental, it's all going to depend upon how we start looking at this. Now, one of the things this book doesn't get into, and we start getting into the next year's classes, if you want to advance in this, is that this experimental probability under law of large numbers should translate to theoretical probability. So as we do more and more trials, so we do 15, we do 20, we do 10 billion trials, we should see that this isn't going to stay at 0.6. It should be getting closer to 0.5. And that's one of the things that is kind of there between experimental and theoretical, and there's a relationship between them, but they still have a slight difference as what they're looking at. So let's look at number 8. Okay, so on number 8, it says a class tossed coins and recorded 161 heads. So we have 161 heads, 171 tails. It asks us, what is the experimental probability of a head? Okay. Well, the experimental probability of a head is going to be 161 out of, well, how many total do we have? our total, we're going to have to add these together. So if I go 161 plus 171, I'm going to be lazy here and use my calculator. We have 332 total tosses. Okay, and then one thing we always want to do is we always want to see if this is going to simplify down, in which then it doesn't. So then pay attention to directions. Sometimes they'll ask us to write it out in decimal, but in most cases we want to leave this as this fraction right here in simplified format. We generally don't want to go to a decimal. Now do remember, all our answers in here will be from 0 to 1. Okay, so any answer you have is going to be in between 0 or equal to 0 and up to 1. Okay, so I go like this: probability of an event less than or equal to 1. 0 is impossible, 1 is a sure thing. So every answer is going to be some decimal in between these two generally. Very seldom we actually have 0 and 1 for answers within here. But there, I give you the range for those answers. How much more simplified can you have? I mean, how many numbers are in between 0 and 1? It's not like, oh wait, there's an infinity amount of answers in there. Oh, so it still isn't perfect for you. But at least you know if you get a number that's larger than 1 or a negative number in here, you're messing up somehow. Okay, so getting back to our problem then, it asks then, what's the probability of a tail? Okay, so probability of a tail then would be 171 out of 332. Or we could use the complement property, which we'll cover in the next section. Let's jump to number 14. Okay, so on number 14 here it says a jar has 30 red marbles, 50 blue marbles, and 20 white marbles. We pick one marble out of the jar, so you're going to pick one marble. It asks us what is the theoretical probability. Okay, so we're just picking one out and we're looking at what's happening, not experiment. They're not saying, oh well, we picked one marble out 15 times and we got this so many. No, it's saying we only doing this once and here's what you have. So that's why theoretical probability. It asks for probability of blue. Okay, so if we look at probability of blue, we have 50 blues in this jar out of a total of 100. So we see we have 5 over 10, which is 1/2 probability on this. Okay, so we have a 1/2 probability that we would pull out a blue marble. 15 says probability of not white. Okay, so not white. Well, if we consider there's 100 marbles in here, and how many are not white? So white is 20. We look back here. Oh, wait, there are 80 that are not white because they're red and blue right here. So there's 80 that are not white. So once again, that's 8 over 10, which would be 4/5 chance. And squeezing in here, 16 probability of red or blue. Once again, we'll talk about this word or in the next lecture, but in here we're just thinking about this basic thinking, easy problems to be working with. Once again, there are 100 marbles in here. We look at this, how many are red or blue? Well, there are 30 red, there are 50 blue, so there are 80. Wait, red or blue is what not white was saying, so it's the same thing right here. So what we'll start finding out is there's going to be different ways to state answers or to figure out probabilities. They have those same answers, but there's different ways to phrase it. So do be well aware that sometimes things aren't as easy as it seems. Let's look at number 28 then. Okay, so on number 28, says, suppose you roll 2 standard number cubes. What is the theoretical probability of getting a sum of 7? We got to find what the sample space is and what our outcomes are. So we're going to roll 2 number cubes. Now I'm going to do this one in a table format for my sum. So if I consider what's happening here, I'm going to go like this. I have 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. This is a very common problem, something you might want to put down, especially if you ever want to play craps out in Vegas or any casino that offers it. Excellent way to try to figure out your probabilities in there. Once again, probability in mathematics will make you a good gambler if you let it. Here we're talking about the sum. Okay, so I'm just going to go on red here. So you could roll a 1 and a 1, meaning that your sum would be 2. You could roll a 2 and a 1, which would be 3. Or you could roll a 2 and a 1 the other way. So once again, you could have a difference of the first number cube could roll a 2, then the second one would roll a 1, or the second one would roll a 2, and the first one would roll a 1. So there are actually difference in here. So we see that this then is 4, 5, 6, 7. 4, 5, 6, 7, 8. Once again, 2 plus 6 is 8. Hope I'm not going through this too fast, but I don't want to waste too much of your time here. So 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. So if we look at, there are a total, once again, fundamental counting principle. Okay? We're going to roll one number cube which has 6 outcomes. We're going to roll a second number cube which has 6 outcomes. We have 36 total outcomes. If you notice, I just mapped out in a table my 36 different sums that could happen because of the possibilities. Now notice we have some repeat of them. If we consider what's happening here, it asks us to find the probability of the sum of 7. Okay? So the sum of 7. If we consider what's happening here, notice this diagonal right here. These are all our 7s. We have 1, 2, 3, 4, 5, 6 different ways to roll a 7. Okay, so 6 out of 36 is 1/6. Okay, so we have a 1/6 chance of having the probability of rolling the sum of a 7. Now do realize on these other ones we start looking at that we have 36 different ways. Notice this is a 4 and a 3, a 4 and a 3, but one is coming from one die, the other is coming, then it switches on the dies, so there are actually different possibilities within here, even though their sums are the same. So this is one of those things that really kind of starts playing into our probabilities on what is our total sample space, and then what do we have going on. Once again, this is a theoretical probability. So in theory, we should be seeing a sum of a 7, 1 out of 6 rolls. Now, is this going to happen in real life? Probably not. Okay, it could happen more often. It could happen less often. It's just one of those things that you can never truly predict anything, but the theoretical probability is always there. And then there's that experimental probability that we could also be looking at too. Once again, the difference of having an experiment and just the theory of what is possibly happening is what this section really starts delving into.